Hello everyone, my name is Nur Wakhid and today I will present our research with title Distribution of Pit Soil Carbon under Different Land Uses in Tidal Swampland. The pit soil is an organic matter decompositions from organic matter decompositions and tropical peatland even only about 17% of the global pit carbon pool but store a huge carbon. And Indonesia has the largest area of tropical peatland in the world. Thus, the peatland in Indonesia is important for global carbon balance. Peat soil is usually associated with the swampland under waterlogged conditions, both in freshwater and or tidal swampland. The logged conditions bring through slow decomposition of organic matter under anaerobic situations that form the pit soil. However, the huge sea deposit underlying pit soil is now vulnerable because the land use change have been expanded. Usually, the land conversion will, will accompany with the drainage contractions, and as a result, the pit soil characteristic will be changed, and the pit sea deposit is potentially decreased. Thus, it is crucial to quantify the sea deposit of pit to determine the effects of land conversions. The objective of this research was to quantify the distribution of pit soil sea deposit under different land uses in tidal swampland. The study was conducted in Pulang Pisau, Central Kalimantan. The study originally was pit swamp forest that was degraded due to the failure of mega-res project in the late of 1990. We have three different land uses. First, intercropping of rubber and pineapple, rubber mixed with shrubland, and the shrubland. This is the figure of plot setup. So the sea deposit was estimated from the soil sampling that collected within the 5 plots on the transect using the pit auger. And the sample were collected deeply until the pit auger reached the substratum, and we stratified based on the maturity of the pit. The groundwater level also was measured in each plot at the same time during the pit soil sampling. And here, the pit maturity was estimated directly in the fruits using 3 indicators: the decomposition states, color, and by squeezing the pit oil in the palm. The pit maturity was divided into sapric, hammic, and fabric. We quantify the sea deposits using the sea content, pit bulk density, and the pit depth. Here, this is the calculations of carbon deposit measurements. Here, we can see this is the figure of the pit depth in our study site. So the pit soil in here was dominated by sapric and hammic. The pit depth was varied between until the 5.7 until 8 meter and only 5.4 meter in intercropping rubber and pineapple, rubber mixed with the shrubland and shrubland. The pit depth in rubber mixed with shrubland was significantly different with intercropping of rubber and pineapple. And this is the figure of variation of bulk density from the tree side. So the mean of PD was, the bulk density was 0.16, 0.19, and 0.20. The highest was in shrubland. The bulk density in intercropping of rubber and pineapple was significantly different from the bed bulk density in shrubland. This is the figure of C content from our study site. So the mean of C content is about 46, 49, and 43% in intercropping of rubber and pineapple, rubber mixed with shrubland and the shrubland. The shrubland has the highest bulk density with the lowest of C content. Here, this is the C carbon deposit distribution under different land uses. So in rubber with shrubland has the highest carbon deposit under the soil compared to rubber and pineapple and the shrubland. So from this research, we conclude that the rubber mixed with the shrubland has the deepest pit soil and resulted in the highest pit carbon deposit. The pit carbon deposit estimations on swampland are facing some uncertainties as the heterogeneity of the peatland was high. Also, the pit depth measurements as the most factor for the pit C estimations required a lot of effort and very expensive. Therefore, further study is needed to obtain a new method for or model for inexpensive and fast of pit C deposit assessment. Thank you.